So from exercise 5.4, we are going to do number 2, 4, 5, 6, and 7. Now 2 is finding the inverse of a 2 by 2 matrix, and 4 is finding inverse of 3 by 3 matrix. So instead of doing a problem from question 2, I'm just going to move to 4 directly. And if you guys understand 4, should be able to do number 2 as well. So from 2, I'll do A. So for A, what we have is E equal to 4 minus 2, 1, 7, 3, 0, 2, 0, 1. Okay. And what we have to do is calculate the inverse of this. So remember the 6-step process. First step is to check for squareness. E is square matrix. Since, this is 3 by 3. Number 2 is checking for non-singularity, which means we have to calculate the determinant of E. So we have to select any row or any column. I'm going to select the third column because it seems like it's going to be easiest to work with. So I have 1, 7, 3, 2, 0, minus 0, and a bunch of things, plus 1, 4, minus 2, 7, 3. So that gives me 0 minus 6 plus 1, so 12, minus minus, so plus 14. So what we get is minus 6 plus 26, so 20. So effectively, determinant of E is 20, which is of course not equal to 0. So therefore, is non-singular, which means a determinant, an inverse exists. The third step is to calculate the minors. So M11, M12, M21, and M22. So M11 is, let me just go step by step. So to find M11, what you have to do is ignore this and this. And so what we get is 3001. 3001. To find, no, wait. Oh, so this isn't done. Sorry, I've made a mistake. We also have M13, M23. I was solving a 2 by 2 matrix. M31, M32, and M33. So similarly, to find M12, we come here and we ignore this and this, and that leaves us with 7021. So similarly, we have to calculate the minor element for all the matrices, and what that gives us is, so this will be 7320. M21 gives us minus 2101. M22 gives us 4121. Sorry for my untidiness. This should be a bit more stretched out, but hopefully you all can understand what I'm doing. M31 is minus 2130. 32 is 4170. 33 is 4 minus 273. So what that gives us is M11 is 3, M12 is 7. M13 is minus 6. Minus 2. 4 minus 2. Minus 2. Sorry about that. 7. 12 minus 14, so 6. And if we write down the minor matrix, that is 3, 7 minus 6. This is part 3 done. Let's move on to part 4, which is where we have to find the cofactor matrix. To find the cofactor matrix, we're just going to multiply some of the elements with a minus. So I'm going to write down the minor matrix again. And now, okay, so this one will become minus. This one will become minus, so minus minus plus. This minus minus plus. This minus and minus plus. So what we have is a cofactor matrix, which is 3 minus 7 minus 6, 2 minus 3 minus 7, 26. Let's move on to step 5, which is finding adjoint of E, which is simply transpose of the cofactor matrix. So we have 3 minus 7 minus 6, 2, 3 minus 7, 6. Right, guys, so I had actually made some mistakes, which some of you must have noticed. So which was when we are calculating M23, that is 4 and minus 2. Okay, so as a result, M3 becomes 4 minus 4. So it's 0 minus minus, actually plus 4. So into 3, I'm going to get rid of this here. This is going to be 4. So if that is 4, when we take, this will be minus 4 then. And when we take the transpose, we end up with so this is minus 4, and now we are taking the transpose, so we are going to have a minus 4 here. Okay, hopefully that was all the mistakes that I have made. So we have done up to step 5. Let's start step 6, which is to find E inverse, which is equal to 1 divided by determinant of E times the adjoint of E. So determinant was 20, so we have 1 by 20. And the adjoint we just calculated is 3, 2 minus 3, minus 7, 2 minus 7, minus 6, minus 4, 26. And in an exam, this is it. This is the end of what you have to do. The problem is done. But now, let us try and verify that we do have the correct answer. So if we multiply E inverse with E, we should get an identity matrix. So we have this ability, whenever we're inverting a matrix, we have the ability to verify that our calculation is actually correct. You don't have to do it in exams, but for now, let's do it. So we have 1 by 20, 3, 2, minus 3, minus 7, 2, 6, minus 4, 26. And we're going to be multiplying this with the original matrix E, which is 4 minus 2, 1, 7, 3, 0, 2, 0, 1. Okay. So let's multiply. I mean, if you guys want to, you can always do this. This is a 3 by 3. This is 3 by 3. So this and this are the same, so they conform. And if you want to find the dimension of the resulting matrix, that's given by this. It's up to you if you want to do it. So let's see what we have. We have 12 plus 14 minus 6. We have minus 6 plus 6 plus 0. We have 3 plus 0 minus 3. That's the first row. Second row, minus 28. Is it? Plus 14. Oh, minus 14. So I think I have made another mistake somewhere. So we have to find that as well. Okay, so I found a mistake, which is we have a plus 7 here, but I put down minus 7 here. So this is obviously a plus 7. And so what that means is this becomes a plus 7. This is a plus 7. And this is a plus 7. As a result, what we get is minus 28 plus 6. Plus 14 plus 14. Okay, so I'm just going to apologize to you guys. This must be frustrating for those of you who are actually noticing the mistakes that I'm making, and then you have to keep watching the video without being able to stop me. But, well, unfortunately, this is going to happen often. I make a lot of mistakes, and in a regular class, I rely on my students to stop me before it's too late. Unfortunately, when I'm making videos, that's not going to happen. So you guys will just have to bear with me. So over here we have 14 plus 6 plus 0 minus 7 plus 0 plus 7. In the final row, we have minus 24 minus 28 plus 52, 12 minus 12 plus 0 minus 6 plus 0 plus 26. This was 20, another mistake, I'm sorry. Okay, let's see what we have. So 12 plus 14, 26, minus 6, so we have 20. 6 minus 6, 0. 3 minus 3, 0. Minus 28, plus 14 plus 14, 0. 14 plus 6, 20. Plus 7 minus 7, so 0. 28 plus 24, 52, minus 52, plus 52, so 0. 12, 12, 0, and minus 26 plus 26, 20. So which gives us So that means that this E inverse that we calculated is correct. This part obviously is for your own verification. You don't have to do it in an Excel unless I ask you to. Okay, so this is number 4, 4A. You guys can do the rest, B, C, D. Number 5 is almost exactly the same as number 4. So you guys can do that as well. I'm going to do one problem from number 6. So suppose I do 6A. So we have 4x plus 3y equals to 28 and 2x plus 5y equals to 42. Now, of course, you guys can use the simultaneous equation method to solve this and find the values of x and y. We are going to be using matrix inversion. So in that case, we convert this into the matrix form. That gives us the coefficient matrix, the variable matrix, the constant matrix here. So what we need is to find an inverse for this. Okay, so let's do that. Let's call this matrix A, 3, 2, 5. You guys know how to find an inverse. So step 1, squareness. It is a 2 by 2 matrix, so it is square. Let's calculate determinant, which is 4 times 5 minus 3 times 2. 20 minus 6 is 14. That's not equal to 0, so A is non-singular. Then we have to find the minor matrix. The minor matrix is effectively 5, 4, 3, 2. Then we find the cofactor matrix, which is 5 minus 2 minus 3, 4. Then we find the adjoint of A, which is 5 minus 2 minus 3. So as a result, A inverse is 1 by determinant times matrix. Sorry, not the cofactor, the adjoint. Okay. So now that we have this, what we can do is we can multiply both sides of this equation with what we have. So what we have is and we had 4, 3, 2, 5. We had x and y. And on this side, we're going to multiplying both sides with this. So we put this down. We had 28 and 42. So let's start off by multiplying this part. So that will give us, let's see what that gives us, 1 by 14. So 20 minus 6, 15 minus 15, minus 8 plus 8, and minus 6 plus 20. That times xy equals to, let's do this multiplication as well. So we get 5 times 28 minus 3 times 42. And down here we get minus 2 times 28 plus 4 times 42. Okay. What do we have here? 1 by 14, 14, 0, 0, 14. x, y equals to, we have here 5 times 28 is 140 minus 42 times 3. So 6, this is minus 56 plus 68. I hope my calculations are correct. Take a look here. This becomes an identity matrix. So 1, 0, 0, 1 times xy equals to 1 by 14. This gives us how much? 14 and 112, is it? So if we multiply these two matrices, do they conform? This is 2 by 2. This is 2 by 1. So of course they conform because this is 2, this is 2. So they can be multiplied. As a result, what we get is x plus 0 and 0 plus y, which is equal to, okay, and if we scalar multiply this matrix with 1 by 14, we get 1. What's this is 8. 8, 4, 12. If we simplify, we have x, y, which is equal to 1 by 8. So we found the values of x and y. X equal to 1, y equals to 8. That's it. So this was the 2 by 2 case. As you guys can see, 6b is the 3 by 3 case. And I'm sure you can all solve it. All right, so that is all we're going to do from 5.4. And let's move on to the next video then.